In this lesson, we're going to learn about the expected value, which is helpful in, like, if you had a casino or a carnival game that was based on some experiment that involves simple probability. You can figure out whether or not the house has an advantage over the contestant, which, if they have any kind of sense, of course they would rig it so that they would have the advantage. So we'll see how that works later on here. So first, let's talk about what expectation is. It's essentially the mean. So if there are n trials and the probability that an event occurs is p, then the number of times we expect the event to occur would be n times p. And hopefully that'll be common sense as you see how these things work. So down here in the blue box, we have what the expected outcome is defined as, and you can see here it's each x value times its probability of occurring. Like I was saying, the expected value is the weighted average. So expectation is also, you can think of it as, whoops, I meant to say expected. Well, good enough. Expected value is the weighted average. So it's the average random variable, or in other words, the weighted average, or the weighted average value of all the possible values that x can take on. Let's make sure that makes sense. Expected value is the weighted average of the possible values of x. And you get that by taking each x value and multiplying by its probability, and then adding them all up. It's also what we do when we figure out your grades, like, because we have weighted grades. Like, say in the homework is 10%, let's say quizzes were 10, and let's just say tests were 80, just arbitrarily picking. And then say you had your homework average was an 85, and your quiz average was a 90, and your test average was an 80. You would be multiplying 85 times the percent plus, and you would add plus 90 times the percent plus 80 times the percent. So it's essentially, that's the same idea here. Example 5. Each time a footballer kicks for a goal, he has a 3/4 chance of being successful. In a particular game, he has 12 kicks for a goal. How many goals would you expect him to kick? So this one, hopefully it just is intuitive that if you're kicking 12 times and you have a 3/4 chance of being successful, then it's going to be 12 times 3/4 chance. And so that's 3 times 3 is 9. So you would expect him to be successful 9 times. And that's the n is the number, and then p is the probability. So this illustrates the formula for expectation. E equals np. Example 6. Find the mean. Oh, I forgot to mention the mean is called mu. That is mu right there. I think it's written like so. Find the mean of the magazine store data in example 2 and explain what it means. Okay, and so then I brought up example 2 here. And if you want, you can look back in your notes to see what the probabilities were. So what I'm going to do is I'm going to go back in my notes here and bring up the results that we got when we did that problem. So here are the number of magazines purchased, and then down here we figured out the probabilities. Well, heck, they're just right here. It's just the decimal form. Don't even have to rethink this. So if you put all the decimal forms in here, those are the probabilities. And now it's asking us to find the mean. So we simply are going to be multiplying n times p and summing those up. So I'll write it out in mathematical notation. the summation of NP. So that's going to be 1 times 0.23 plus 2 times 0.38 plus 3 times 0.21 plus 4 times 0.13 plus 5 times 0.05. And if you do the math, you will get, I got 2.39. And then we should put units in there. That's the X value. That's this average X value. And the X values were the magazines purchased. So on average, they're purchasing 2.39 magazines per person on average. Oh, now we get to talk about fair games. So a fair game is one in which the expected return, oh, yeah, I'm already kind of skipping ahead. It's if the gain is 0. So if the expected return minus the cost to play is 0, then the game is fair. So I should say expected here. If the expected return minus the cost is equal to 0, then it's fair. And then the expected return is the expected value that we've been finding. And the cost to pay would be given to you. So let's see how this works with this last example. And I've put several of these in the homework so you'll do enough of them where you get a good feel for how this works. In a game of chance, a player spins a square spinner labeled 1, 2, 3, 4. So it doesn't say, but we're assuming that you have an equal chance of getting any of these. The player wins the amount of money shown in the table. So if they hit a 4, they get more money than if they hit a 1. And it says find the expected return for one spin of the spinner. So on this one, you have to think, well, we know it's going to be the sum of the NPs. And the P is a probability that you land on a 1, for instance. Well, that's going to be, because we're going to assume it's an equal spinner here, that you have a quarter chance of getting any of these. So you're going to have a quarter chance of landing on, or getting $1, plus a quarter chance of getting $2, plus a quarter chance of 5, and a quarter chance of 8. And of course you can factor that 1/4 out, which would be an ideal way to figure that out. So it'd be 1/4 times, and then you'd have 3 plus 5 is 8, 8 plus 8 is 16, a quarter of 16 is 4. So you would expect $4 on average if you play that game. Now, what's the expected gain of the player if it costs $5 to play? So the gain is the return minus the cost. Well, we can see the return, figure it out, minus the cost of 5. On average, you're going to lose $1 as the player if you play that game. So are you going to recommend playing the game? No. So obviously, the person who designed this game was either lucky or they used some math and figured out that they were going to have the advantage over the player. And that's the last example. I've got quite a few of these on the homework, so you can get a really good practice with these. Until next time, goodbye.